high-performance liquid chromatography. Chromatography. Chromatography is a technique which separates components in a mixture due to the differing time taken for each component to travel through a stationary phase when carried through it by a mobile. Two phases. Mobile phase, liquid or gaseous, and flows over or through the stationary phase. Stationary phase, solid, liquid or a solid-liquid mixture which is immobilized. Different types of chromatography. Paper chromatography, liquid chromatography, gas chromatography, high-performance liquid chromatography, HPLC. HPLC is an extension of conventional liquid chromatography, powerful tool in analytical techniques. Columns are tightly packed and the eluent is forced through the column under high pressure up to 5,000 psi by a pump. Allows to use a very smaller particle size for the column packing material, which gives a much greater surface area for interactions between the stationary phase and the molecules flowing through it. Allows a much better separation of the components of the HPLC technique. Utilizes liquid mobile phase to separate the mixture. Analytes are first dissolved in a solvent through the column under high pressure of up to 400 atm. Mixture is resolved into its components in the column. The total separation time is often 5 or 10 minutes rather than hours or even days required for some separations by gravity flow with the larger systems. Flow scheme. Components of HPLC: pump, injector, column, detector. Pump. A pump forces the mobile phase through the column at a much greater velocity than gravity flow columns. The pump can be pneumatic, syringe type, reciprocating, or hydraulic amplifier. Pneumatic pumps are used for preoperative purposes. The most widely used pump today is the multi-head pump with 2 or more reciprocating pistons. Pumps are designed in order to maintain a stable flow rate, avoiding pulsations even when the composition of the mobile phase varies. Flow range 0.01-10 ml min. Injector. Inject the liquid sample within range of 0.1-100 ml of volume under high pressure. Produce minimum band broadening. Produce possible flow disturbances. Volume must be small 0.1-500 all. Column. HPLC columns are prepared from stainless steel or glass Teflon tubing. Typical column inside diameters are 2.1, 3.2 or 4.5 mm for analytical separations, up to 30 mm for preparative applications. Common length of the column 10 to 20 cm columns. Detector. HPLC detectors monitor the elute as it leaves the column. Produce an electronic signal proportional to the concentration of each separated component. Detector. Crucial in trace analysis, high sensitivity, fast response, simplifies quantitation, insensitive to changes in type of solvent, flow rate and These are the detectors used in HPLC. Depending on the relative polarity of the solvent and stationary phase, there are 2 variants in use in HPLC. Normal phase HPLC utilize polar adsorbent surface and non-polar eluent. Polar substance in the mixture sticks to polar adsorbent than non-polar. Non-polar ones will pass more quickly through the column. Reversed phase HPLC utilize non-polar adsorbent surface and polar eluent. Attraction between non-polar compound in the mixture and non-polar adsorbent. Reversed phase HPLC is the most commonly used form of HPLC. Polar molecules will travel through the column more quickly because there is strong attraction between polar solvent and polar molecules when passed through the column. Thank you.